All right, now. I did mention that not every problem is a good mental math problem, okay? I did post a video to the modules. If you look in chapter 2, section 1, the 2.1 module, there is one about what makes a good mental math problem, but we can do some here as well for practice. Okay, so the question we're going to ask here is what I put down going to be a good mental math problem or not? If it is, let's try to answer it. If not, we'll just say not a good mental math problem. Okay. How about this? Good mental math problem or not? It's got 3 numbers, so maybe not, but if we can deal with the numbers relatively easily, then it should be okay. So what do you think? Can we do it by mental math?
Yeah.
I think so, yeah. In fact, it's almost impossible to come up with an addition problem that you can't do with mental math. So what we do, we're looking at this thing here. I'm seeing 31 and 79. What should I do?
Move the one over.
Right, maybe a compensation here. Put 1 over there. So we do 30 plus 80. That's 110. And then we tack on the 12. 122. Okay, so if you got just addition, it's a pretty easy mental math problem some way or other. Use your compensation. What if I were to do this? I mean, we talked about some multiplication techniques, right? We talked about 2, 4, 8. We talked about 5. We talked about 9. We talked about 11. We didn't talk about 3. Does that make this a bad mental math problem? What do you think? Can you find the answer? Yeah. Okay, what's the answer? 93, okay? So just because something involves a number that we didn't specifically talk about, it doesn't necessarily mean it's not a good mental math problem. Okay, here, you can just deal with the digits individually. There's no carrying or anything like that. And that's what makes the difference between a good mental math multiplication problem and one that's not so good. Okay, so now if I were to ask you to do, well, we could probably do something with this too, but okay, this is going to get hard. Okay, this is not a good mental math problem, okay? Because there's carrying. All that stuff. So that's just not a good mental math problem. Okay, so that's basically the theme in deciding whether something is a good mental math problem or not. All right. Now we're gonna move on to the next section here. If you haven't already done this, please read through section 1.7. There were no exercises for 1.7. So make sure you just read through that section. And then start chapter 2, section 1. Starts on page 43 of Elementary Math for Teachers. And it goes through page 46. So 43 through 46. And work on these mental math practice problems here. Okay? Work on the mental math practice problems on page 47. Okay, check. I think it's go 1 through 5 in the module there. or sorry, look at the module, I think I wrote down which ones to do, but problems 1 through 5 on page 45. Okay, so we are going to move on and discuss section 2.2. Okay, so remember, the exam next Friday is going to cover chapter 1 and chapter 2. Between today, Monday, and Wednesday, we're going to finish the last 2 sections of chapter 2. There's only 3 sections altogether. The last 2 sections are about word problems. Okay? Okay. So, the ideas from this section. I will need you to know what I mean when I say a teacher's solution to a word problem. Okay, there's 3 components. Bar diagram, a computation, and a sentence. Okay, so when I say write a teacher's solution to this word problem, I'm expecting to see a bar diagram that illustrates what computation we should do. I want to see the actual computation. Many of these we'll be able to do with mental math, and then write a sentence for your answer. I guess that's really the key idea with these from this section. Okay. And I guess the other thing is, what makes a good word problem? Okay, so let's deal with that last part first. Word problems should be short, clear, and succinct. Okay. In other words, word problems should get to the point. You ever look up a recipe online? What's the trope? You look up a recipe online, and what do you have to do?
Scroll through their life story.
Right, you have to scroll through their whole life story. I just wanted to know how many cans of diced tomatoes I needed for this thing, okay? So don't do that, get to the point when you're writing a word problem, okay? Now, when I say when you're writing a word problem, you're gonna be a teacher. You gotta write tests, okay? There are some test banks and things to help you get started, but you need to be able to write your own problems, okay? So, when you're writing a word problem, get to the point. Should be just a couple sentences, that's it, okay? It should be interesting but not embellished. In other words, there should be a reason somebody should want to find that out. If we're talking about somebody, let's say they have a dozen eggs, they need 1 egg for their brownie recipe and they need 3 eggs for their bread recipe or something like that, that's something somebody would want to find out. Okay, but don't make them too outlandish either. Okay, realistic, in other words, not contrived. We'll see this in the examples that we look at. And they should also be self-contained. In other words, there shouldn't be a need for outside information, because sometimes you can end up testing 2 things without really knowing it, if you don't do a self-contained word problem. Okay? So, let's just go and get to some examples here. If you've got your book set, open with me to 3A. Looking at primary mathematics 3A on page 66. And these are pretty short, so I'll just write 1 or 2 of them on the board here. On 3A, page 66. I'm looking at number 6 here. Farmer has 64 goats. He has 5 times as many cows as goats. How many cows does he have? Question mark. Okay. So I think the numbers are somewhat reasonable. If you have 2 goats, you're not really a farmer. You're just somebody that has 2 goats. Okay? So you're a farmer, you probably have a lot of these animals. And if you're a farmer that has cows, you've probably got a lot of cows. Okay? Just, drive from here to Oklahoma City, you'll see fields with all these cows in them. Okay? So it's a fairly reasonable thing. Okay, so let's get to our bar diagram. So, we're interested in how many cows he has. So, I'm going to start with a bar like this. Okay, so why did I break it up into 5 pieces?
5 times as many.
Right, he has 5 times as many cows as goats. So that means, well, firstly, he has more cows, right? He has 5 times as many cows. Okay, so this whole thing is the number of cows. So the question that I'm trying to answer is, how long is this entire bar? All right, so we've incorporated the 5 into the picture because the bar has 5 pieces. There's another number in there that I need to use. Where should I put that number?
The 64 goes in the box.
Right, the 64 would be the size of one of the bars, one of the pieces. So you could say, okay, put a 64 there, you put a 64 there, somewhere in there, okay? So the picture is showing where the 5 is coming in, the picture is showing where the 64 is coming in. What computation should we do? It's a multiplication problem, right? Because 64, another 64, another 64, we have 5 groups of 64. So we should do 5 times 64. How can we do this with mental math? Okay, cut that in half, multiply by 10. Remember that technique here? This is even, so it kind of works out, it works easier to do it that way. So take 64, cut it in half, what do you get? 32, right? Now take 32, multiply by 10. 320. Okay, almost done. There's one thing I have left. Bar diagram computation sentence. The problem asked us a question. How many cows does he have? We should answer that question. He has 320 cows. Okay. Let's see. Where's a good one? Okay, this is a two-step problem. Steve packed 215 oranges into bags of 5 each. Sold them all at $2 a bag. How much money did he get? Question mark. Okay, so slightly more involved. As I was writing on the board, I said this is a two-stepper. Of course, what I mean by that is we're going to have to do 2 computations to get the answer for this. Over here, we only had to do the 5 times 64, and then we were done. All right, so let's think about, whoop, $2 a bag. I said that, but I didn't actually write down the 2. Okay, so let's think about what we need to know to answer this problem. So he sells all these bags of oranges. Each of the bags gets him $2. So what's the first question we have to answer?
We gotta figure out how many bags he has.
Right, we gotta figure out how many bags he sold. Okay, so he took 215 oranges and he divided them into bags of 5. Okay, I kind of gave away something important there. I kind of basically said the operation that we're gonna need to do, right? What operation do we need to do? A division operation. Okay, it's a division problem, at least the first step. Now, is this partitive division?
No.
Yeah, this is measurement division. Okay, I know I got 215 oranges altogether. Right, so when you start to draw your bar diagram, then you'll see why it's measurement division. So we have a bar, and the length of the entire bar represents the total that we have, in this case, 215. Now, should I divide this into 5 pieces? Is that what I should do? No, probably not. What should I do? Okay, so I'm going to carve off 1 piece, and that is length 5. How many pieces should I have? We don't know, so that's what we're going to need to find out. And that's why it is measurement division, okay? When you're thinking about the difference between the 2 things, imagine this, you want to measure this entire length. Imagine you have a ruler that is length 5. The question is, how many times do you have to measure off 5 to get to the end? If you're answering that, then you're doing measurement division. Partitive is when you know how many parts, okay? So, the question is, how many of those bars are there? So we're gonna do 215 divided by 5. Okay, so, how do we divide by 5? We just talked about it in our little review. Right, we double 215 and then we divide that new number by 10. So I double this. I get 430. Okay, not too hard, right? Double the 200, you get 400. Double the 15, you get 10. 430, or sorry, yeah. Double the 15, you get 30. Okay, and now you divide by 10. So what's the result? 43. Okay, so did I answer the question? Should I say he got $43?
No.
No, I'm not quite done yet. What do I have to do? Right, now we need to double 42. Okay, so 43 times 2 is an easy one, 86. So what's wrong? Right, that's abuse of equal sign, right? We kind of get what the person is saying, but they really shouldn't be saying it like that. This is saying Steve is the same as 86. We should answer it in a sentence. So Steve has $86. Okay, so we got our bar diagram. In this case, we needed 2 computations, and then we have a sentence for our answer. Okay, so we're going to continue working on word problems on Monday. You guys that are coming into class, bring primary math 3A with you, and do me a favor and also bring okay, we'll just work on 3A. So bring 3A with you. What are we working on for homework? Yeah, 2.1 stuff, those mental math problems, read through section 2.1, do the mental math problems there. And then we'll continue working on word problems Monday and Wednesday. Okay, don't forget to look at your grid so that you don't get surprised